Hi, I'm Nick Chase from Cloud Geometry. Welcome to our series on platform engineering. We've been doing platform engineering since, since before it was even a thing, and we've noticed several problems coming up again and again and again. So we built our own reference implementation. It's called CG DevX, and that's what you're going to see today. Now, platform engineering is meant to ensure that your developers never have to think about anything but development. So we've been building out CGDevX to take care of the tasks such as setting up an entire environment for the developer and helping to manage workloads, DevOps, security, and so on. But let's start at the beginning. Let me hand things over to my colleague, David Fishman, who's going to show you how this infrastructure setup process works.
Hi there. In this video, I'm going to explain how we set up a complete environment that allows your developers and your DevOps team, your operations side, to quickly set up everything you need to build and run cloud-native applications in less than an hour. Now, the best part is we used a lot of industry standard and open source tools like Terraform and Kubernetes that you can use to host production environments. And like I promised, it'll be ready to go in less than an hour. So we start with creating a machine user in our version control system. That'll be used by the system to create all the repositories that we're going to need for system provisioning and core components delivery. Now, it could create, and we'll show this a little later, a repository for application and inject the various CI and CD configurations. But for this specific example, we're going to use GitHub because it's the most popular version control system, VCS. And of course, it has tons of additional functionalities, so everybody knows that. But we can support other systems like GitLab or Bitbucket, but for this purpose, we'll use GitHub. And here we start with an empty GitHub organization. And as you can see, we have no repositories, we don't have any runners, we don't have any keys, etc. So to get started, you'll need a user with owner permissions, and we've already created such a user here under our demo organization. And it's better to give this user an easily distinguishable name and securely store that user's credentials. So what we need to do next is generate an access token that we will provide to the provisioning automation system that we've put together. So here we have the token, it's already added. And now we're going to go and show you in the IDE what we think is kind of part of the secret sauce, right? We believe that one of the key components of enabling reliable repeatability of provisioning is to be able to decouple configuration from the CI/CD process itself. And you can see this in a lot of other projects, Kubernetes, GitOps, other kinds of infrastructure as code, and other popular technologies. So here, this is a main configuration file that's used by our CLI helper scripts to parameterize Terraform and TerraGrunt as which encode our provisioning process. So here's how we're going to set this up. The first thing we'll do is we're setting parameters starting with an admin email for alerts, a hosted zone name, which will be the domain name for this environment, and then we'll specify the cloud region, the region for, let's say, your AWS region. This will be specific to your cloud provider. We're going to name a cluster for the Kubernetes cluster. Again, we're doing this with Amazon. We'll have the repo provider, which is GitHub, and a name of an organization for GitHub. We're just going to copy paste this. Okay, so we're done here. Now let's move to the cloud environment. In other words, here it's AWS. And as you can see, the account is empty. We're going to use AWS just, again, we use AWS all the time. You might use something different, but for the purpose of this demo. Now, even though the core of our runtime is Kubernetes and it's technically speaking managed Kubernetes on AWS, the truth is AWS, GCP, and Azure are essentially identical. So we can deploy what we're showing you here to any of them, whether it's in a managed setup or something that you do in a self-managed with a self-managed approach. Now, if you go with self-managed, it also allows you to go on-prem with vanilla Kubernetes or any other Kubernetes flavor that might fit exactly what you need in your environment, other than some of the the popular distros. So as you can see here, we have a completely fresh and clean account in this region, the selected region, as part of our organization, and we are provisioning it according to the practices of the well-architected framework, which, by the way, we use this all the time. It's really a great way to kind of lay some ground rules for setting up your infrastructure and governing your workloads. So what I'm showing you here is here's a hosted zone. We created it. It has no records. It has no EKS clusters. There are no EC2 instances, and we start with nothing but the default VPC. Good. Okay. So now let's invoke our little CLI helper script. As mentioned before, we're going to use that YAML file to populate parameters into Terraform and TerraGrunt and start the process. What this is going to do is as follows. It's going to create a new GitHub repository for our infrastructure as code. It's going to inject GitHub actions for CI. It's going to create and configure cloud resources like VPC and S3 bucket for Terraform state and IAM roles and an EKS cluster, Route 53 in the case, because this is in Amazon and so forth. And then we're going to add a HashiCorp vault. And starting that HashiCorp vault is where we'll do secrets management, because this is set up to be cross-platform. We'll use ArgoCD for GitOps continuous delivery. And last but not least, we want to simplify IAC workflow management, and we're going to use Atlantis. So there's a lot of stuff going on here under the hood as provisioning and configuring all those tools could, if you had to do them one at a time, it would take a while. So we've got this all set up to kind of work at a chain, and let me explain to you how all those things work. So the first thing we'll do is we'll check Terraform logs, and as you can see, the first new resources here are being created. That whole process can take most of the time that we have allotted. It's usually about 30 to 40 minutes, depending on variations in AWS resource availabilities, time of day, maybe your internet connection speed. But using the famous baking show trick, we're just going to edit that 30 or 40 minutes out, and just like that, we're ready to go. So imagine we're ready in the next part of the demo. 30 to 40 minutes have passed. Let's look at how all this ran based on how our GitHub account is now set up. So here we have called this GitOps. It was actually used to provision all of the resources on AWS. And so from now on, any changes to the infrastructure need to be done through this GitOps repo. In addition, we set up a couple of different teams user teams with different roles that we're going to use later on for both user management, access management, and we're also going to configure self-hosted runners for executing GitHub actions. Now, moving to AWS, let me show you the new resources that are set up. See, here we have hosted zone records, EKS cluster with 6 nodes. And you can see all of them when you look at it from the perspective of EC2. And here is a new VPC. So moving right along, let's take a look at how the Kubernetes client is set up. So as part of its output are a little helper configuration magic provided a kubeconfig file that we're going to now use to connect to our cluster. So first, let's check the nodes. And here you see the existing pods. And what you see here is ArgoCD, Vault, and Atlantis are services that are all up and running. So let's check those and make sure that they're set up. So first, we'll take a look at Vault and then at ArgoCD. Links and credentials are provided as an output of our automation, and we'll mask them for security, etc. You just have to take our word for it. They're behind those blurry little video editing magic, there really are passwords. All right, now let's take a look at Vault, which is where we have secret management. So we're using HashiCorp Vault to manage secrets because when we use it to integrate all the components of the systems, the various components that are running and so forth, we gain the benefit of centralized secrets management and dynamic secrets delivery. So let's log into Vault using the credentials that our automation provided. It's an important note, don't use this account for ongoing management, and anybody who needs to access Vault in terms of new users should use the users provisioned by the system via the infrastructure as code setup rather than backdoor workarounds and whatnot. So here's what we've set up. We have a pre-provisioned environment with cubbyhole secrets. And this, you're using the Vault cubbyhole secrets engine, which is backed up by physical storage on the cloud, of course. Secrets will store the various passwords and credentials as secrets for the components like ArgoCD and whatnot. And then we also have another section of Vault where we have set up the user credentials. All right, so this altogether shows all of the parts of the cloud geometry, cloud native quick start kit in one place, all under Vault, well structured. So all of the services are their credentials and whatnot are well managed. Now let's move to ArgoCD. So we are using ArgoCD to deliver the components of the systems and the component systems, and also your workloads into the Kubernetes clusters. And we do so in a unified, well-defined, repeatable manner. So how does this work? Well, we're going to log into ArgoCD using credentials provided by our automation. And here you'll see that all the pipelines that we predefined for platform components delivery are already set up. In fact, what you can also see, if I can point this out right here, we also have ArgoCD connected to GitHub, and you can deploy any of this to the Kubernetes cluster because it's wired in with GitHub. So now what you would have had to put together one piece at a time is ready to go, right? If you've got an application written into your repo, now you can just push that right through. So the demo is done. We are ready to get cooking.